So that's for our first line tracing part. And after that, what will be needed is we will be needed another node from here. So let's take a branch, and then from here connect that to the branch. So now we got our branch. Let's keep it here. Then what we will do is control hold this one, this one, this one, and this one. So hold control and then you drag and it will do this. If you hold alt, then it will be set. If you don't know this Unreal shortcut, so I explained. After that, what we will do is from here, first thing we will check that if these and these, if these two, let's keep it here. If these two is true, so let's come, yeah. So after that, from here, we will take a select node, yeah, this one, and we will duplicate or control C, control V, whatever you are preferable. So yeah, like this. For the timing, just do what I did. We will change the value later on. Now what we will do is, again, the wall right will go here, the wall left will go here. And you can see once we change the index, it has changed from true, false, from option 1, option 0 to false, true. Now this false, we will, this one we will connect to the false, and this one we will connect to the true. When for this one is true, then this will be our right wall hit. If this one for this one wall left hit is true, left one, if false, then the right one. And we will promote this to another variable called found hit result. So now for the true node, we will false node we will connect here. So let's keep it a bit lower, as we need here many codes to do, so we need some space here. And after we have this false set, now for the true node we have some codes. And yeah, so here the first thing we have done, this one we will name as filtering hit results by wall direction. So we got this, and after that, here the first thing in the true node we will take, uh, let's keep some space, and here we will again control hold and take this two. Now we will break, again copy paste for this one too. So now what we will do is we will take the distance and less equal, then we will take the distance less equal, and here from the true node, we will call this and take a branch. So this one we will connect. So we are checking if this is less than the direction, the right hit will be our main priority. If this one is less than this, if true, then here let's comment this down. So this will be if there are two walls, then get the closest wall. So by default, we will calculate our right wall as our closest. But again, if there are two walls, we will check that if the left one is closest or not, because we don't want our player to get confused that which wall he need to now perform the wall running. So after that, if it's true, this found result, this one will be our right. This one will be our right wall, because we are checking that if right is less than the left. So if this is true, we will do like this. After that, um, we will set this to true, and we will set this to false. Then we will again duplicate. Okay, so we will again duplicate this, but this time we will delete this. We will set this one, and after that we will untick this, tick this. So this will be our false, means our left wall is now nearest. So we will select desired wall. So now as we have all these, and now we will work on our false node, this one we got. So let's keep it a bit lower, and this one let's take here. we need more space here because this code will be way more bigger. So I guess the best option is to put this as lower as possible. So we have done that. And after that, now zoom. Now we will work with this. So for everything, what we will do is from here, we will take a reroute node. We will connect this one also. We will connect our this one also. So after connecting them all, let's make it straight. Yeah, this one. So after making this, what we will do is our first work will be take this one, then break hit result, and from here we will take a branch, so blocking hit, and if it's false, then what we will do is we will take another branch. If it's false, we will take another branch while running ongoing. Then we will set the while run completed in the true node, and we will tick it. So this is basically if the while run is ongoing and our everything what we did earlier, that filtering, if it's blocking anything, then we will count this as completed. So then in the true node, we have many works to do. So the first work we will do is from this normal, we will promote it to a variable normal of surface and connect the true node. After that, we will take get actor up vector. Now here we will take this and we will do a dot product, where from here I will take dot product will be from, connecting these. Here we will take in range float. So minimum value will be 0.0, sorry, 0.2, and the maximum value will be 0.2. So this one will be negative, this one will be positive, and then we will connect another branch here and connect this. So after that, we need few more things, but let's first, this one will be our comment. If running while is over, then reset variables. And after that, here, yeah, after that in the true node and in this branch, what we will do is before this branch we have some more works. So here the first thing is go down. I guess this one is not needed, just drop to sidebar so that we can have some space to work on. And after that, in the below section, we will from here we will multiply, and this will be integer, and this will I will take negative, so this will be negative. And here will be select this one, and the branch will be wall right hit. So if we hit the wall, if this is false, then that means we will check our up vector for the left side. If we hit, then we will check for the right side. So after that, from here we will do a cross. My keyboard. So we will take a cross here, and this second node we will take from our normal, this one. So this one will be the cross second node, and after that we will normalize. So keep it as it is because we don't need any changes here. So far, let's give it a comment so that we can understand later on what we did this code for. Always try to make the comments if possible, so that you understand next time you start coding that okay, you did this code and for these purposes. So now we got our branch, this one, and we got this one. So after that we will be needed one more calculation. So in the middle part, first thing is from the normal, I guess. So from the normal, and I guess we have this, so we can use this. So from normal we will multiply, and this one will be our float. and we will promote it to a variable called wall offset. This one will go here, this one will also go here. So this one will be our wall offset, and by default we can set a value. Let's give it a value of let's see what happens if we give a value of 50. So here we have given a value of 50, then after that plus vector plus, and for this we will take something like this again. Okay, so it don't work this way, but anyway, again, so this time we will work with our impact point, so connect this. This one again will be our float. This time we will promote it to a variable called length, and by default its value we will keep as 1. So okay, we have got our 1, and after that here we need a one more calculation actually. So we got this, and from here we will do a vector plus vector, where this one will be our second node, and the first node will be our impact point. Okay, so we are taking this impact point from here. I guess we did some mistake here, so this one will be this and this one will be this. So now we got the correct value, and we will connect, and after connecting you can again rename this uh, add a offset to so this is it. And now we got few calculations, we got our offset, that how much distance actually we want our player to be stay away from the wall, because we don't want our player directly go inside the wall while performing the animations. So that's why we have this wall offset, and we have the length that we want to, I mean, keep it. If it's -1, that means for the left side wall we are doing something. If it's +1, then for the right side wall we are doing something. So the offset will work that way, we have set. And now as we have these values, so the next thing we will do is for this true node we will set another sequence. So now we got a sequence, and here what we will do is we will take the first thing. Let's keep it here. I guess we need more space. Yeah, let's put this one a bit higher. Let's put this one a bit higher, and after that what we will do is here from here we will call another branch. Let's keep this branch as it is right now, and okay, for this we need another variable called, and this one is just a causing issue because I have undock it. So if we don't dock it, then every time we create a new variable it will tell us to rename. So here the thing I will do is have check for correct angle, or the best option will be if found correct angle, which means we have found the correct angle to do something. Okay, so we already created that. And after that here for the second one, this one, I mean the first one, we will do is get actor rotation, and from here get actor get right vector, and this one we will do as dot. So here will be the dot product, and for the dot product what I will do is from the normalize we have this one will go here and the normalize will go here, so we are making the dot between these two. And after that we will call for echoes, yeah, degree 1. So we need this one, and here for the angle defining we will check if less than and equals to 90°. And another one we will need is if greater than and equals to 90°. So now we will call a select node. What happened? Where is, yeah, this one. So we'll call this connect. Okay, this one we can connect. So for this one, actually, oh, sorry, my bad. So here the index will be actually this one, and this one will go for the false. This one will go for the true, and we can even keep them here for better organizing. Now, as we have that, and from here we will take a branch. We will call and connect the branch, and this one will go here. And after going, now what we will do is what to do, okay, so we will take get actor rotation again, then we will take it forward vector, and we will again do a dot, and in this dot, like previous, we will again normalize. So this one will again come from the normalize we have, and again we will take this, so just copy paste. Now we have the forward and the right. So after that, in the true node, we will in range float, and here the minimum value we will set like 10, and maximum value will be 40. So now we have another branch, and we will set that true to here. So this one will go here. We can again even put it a bit higher for betterment. So now as we have our right hit, I mean the right and the forward one, so then we will declare that okay, we have found our correct angle. Now if we don't get something, I mean correct angle, we will do nothing, but as we got the correct angle, we will do something. So the next thing we will do, and before that we will rename this. So the entire thing we will rename as, I mean comment as check if player is running in correct angle. So this one is for angle we are defining. Now once we have these, from here we will do something. So let's put a sequence here again, and this one will be very useful for us. So from here what we will do is we will take a custom event, enable wall run. Now inside this we will do something, and here we will call that enable wall run. So this one we have called, pretty good. Now here inside these we will write some codes like do once, I guess I'm doing some mistake. Okay, got the point where I'm doing the mistake. So this one will be like this, sorry, my bad. So we will connect this here. Our sequence 0 will go to this, and this enable wall run, every time we'll call this will reset this. So after that we will drag our character movement, then set movement mode to something called flying, and after that we will set wall run ongoing to true. Then we need some functions, so let's create some. Actually not function, we will make some events here. So the first one will be custom event increase spring arm length, and this will be decrease custom event decrease spring arm length. Now what we will do is we will create a timeline, add timeline, give anything like spring arm length. So first we will see what is our camera boom, which is a spring arm length is 400. So let's open this, and here the time we will set is 1. Then we will take a float where the 0 index will be 0. Oh, sorry, what happened? Okay, I will see that. This one will be length, and why 0 is not taking? I'm confused actually. It's not taking 0. That's very much. Anyway, for the 1, and this one will be 1, and for 1 our value will be it's just 500, so let's keep it around let's try 600. So this one will be our thing, but I'm not sure why it is times 0.0 is not okay. I guess just 0 it is not taking, but if we take it to 0.0 or something like that, then it take. But anyway, our work is done here. So as we got our work done, so increase is the play, decrease is the reverse, and after that what we will do is we will pick our camera boom here. From then we will set target arm length, set update will be update, and length will be length. So we are all done here. So this is increase and decrease uh, cam I guess the best will be zoom in or out based on wall run. So this can be a very good comment for every, I mean, this part. So after that, let's go to our position again. And here, so here we will call our, where this, yeah, here we will call our increase spring arm length. So, yeah, this one. So we will call this. After that, we will take get player, player controller. Then I will set ignore move input. So this one will be ignored. And after that, what we will do is again another branch, and we will check if our was in air is true. Then we need few more variables, and this time it will be float. So max height, and we will set another of z value, and these both will be float. So here for the true one I will set, and this one. After that, just copy paste and connect here. So let's keep things together. Okay, so this one will be 2, this one will be 250, this one will be 90, this one will be 0. And we will comment adjust arc values if player was jumping into 1. And for the remaining part, where it is, yeah, this one, we will rename this whole comment. So this will be toggle required properties to initiate while running. Okay, so we are done here. Then the next step will be our then one, this one, and I guess here also we need two. So the second one, for the second one we will take it actor location, and then we will v interrupt to constant, and this time we will have get word delta second. This one we will connect to the delta, and for the target we will take our wait, for the target, yeah, this one we didn't connect it anywhere, we just will connect now. Okay, so in case you guys missed where I connected, So here you remember this one, add offset player calculation. There we made some calculation which we didn't connect it anywhere. So this one I am using again for this tangent, sorry, target. And our enter speed I will give 600. So after that, from here we will break vector, copy paste, and this one also. So 2 we got. Now from here uh, we will set actor location, and for these we will split x and y will go from here, z will go from here. So now we got our this part, and after that we need our set actor rotation also, but this time wait a minute. Yeah. So from our normalize we have created, yeah, this one. So from this one we will drag and write rotation from x vector, and we will connect this. So we got our rotation and our location here. Then what we will do is here the length value we had, length, we will set it to plus plus, I mean increment float, and before that we will set these to lerp player location along points and set its rotation to calculated vector direction. Okay, so after that we will connect these to here. Then we will clamp float. So clamp float, and we will do this so that, okay, the first, then the next thing will be this, and we will connect. So here we will do is 800. So we don't want our value to go more than 800. So get next point of the vector along the wall. So this part, if you want, you can customize. Everything is customizable. So I will show when I show the showcase that why we make something and for what. Now for the third one, we will connect these here. Okay, so for the third one, first thing we will do is was in air. Yeah, this one. Select. Where is the select? Yeah, this one here. And here, what we will do is for the false, and of course we will connect. First, we will take these z value, then f interp to constant. The interp speed will come here. Delta will be this one, and the target here we will set to a value of 180. Then this one, if true, we will take 10. If false, we will give 100. So then we will connect here. Now we got our z value working. From here, sine degree. So previously we took cos, now we are taking sine. So now from here we'll take select node. We will connect our was in air here. If okay, so this one is not connected here. So okay, so for this one we'll take a branch, and we will use this later on. For these we will multiply now the next thing here is z value. Z value is greater than or equal to, so the value will go this. So now we have this working. as we have this working now, for the false node, what I will do is 179, and the true node will be again 179. So I mean, in both cases it will be 179. So just the select we are using because we need to check based on was in air, not directly, else I would have given the 179 value. Here actually it's 180. Anyway, let's keep 179 because nowadays Unreal causes some minor bugs, like if you rotate a character 180 it calculates 179. So that's the case here. I don't want to break its flow actually. That's why I didn't change it to 180. Let's keep the 179. After that, so we will take our max height, then we will multiply it with the get word delta second. So after that, then we will multiply it here, and from here we will have another select. So this one, the value will go from here actually, not here, from here, if greater than or equals to 90 degree. Then we will check few things. So for true node, what we will connect, the false node is correct, so the false node will be coming from the sign, this one, the sign, and the false node we will write something minus. So this one will go here. This is basically 1 minus we are doing. So after that, we will again multiply, and again this one will go here. So here we will change it to integer and it will be -1. And after that we will do the same checking we did here. So copy and multiply both. So now as we multiplied the value, it will be going to the true node. And if this one is true, we will set our while run completed to true, means our while running has finished. If false, then we will take our capsule component. From here, add world offset, and here we will connect these, where we'll split this, and our this value will go to the Z. So that's for this part. Now our this entire part we will comment, right? Calculate arc, uh, arc path based on sign value of the degree. So this is our part, and after all this done, we have few things to do. So now we need to go to our jump. So our primary coding we have done is done, and for safety, where from where you just started, yeah, it has been started from these, so we can comment everything, comment it as entire while running mechanics, and this time I will give it a white and 100%. If you want, you can give another color for beautification, but anyway, so these are our entire code for while running. Now we have one more thing to test in the jumping part. So for that, the best option can be we shift them upward because we need enough space here. Okay, so for this, I guess this one will be downward because the most of the part is coming from here. So okay, so first disconnect these two. We will use them, but not just now. rename it first if while running. Sorry, I renamed wrong thing. So anyway, for these, if it started, first thing we will do is take a branch. Here in the branch, we will check if while running ongoing, and again, then here we will see is while run. Okay, so here if true, we will check if while run completed. And here, one more thing we need to do is, first of all, take our normal of surfaces, multiply with a value called almost 1000, break vector, then from here add 100, and then connect to make vector, and from here the true part. After that, if false, then we will connect the jump, and if true, from here we will take rotation from x vector, yeah, this one, and after that we will here set actor rotation, and the rotation will be this one. After that we will launch our character, and the launch velocity will be this, and we will call our reset while run. So this is actually the jumping code. Now this one will go like this. This is our jumping code, and here we will do the commenting like if while running, then jump on surface normal direction. Okay, and for the false node, of course, we need to stop jumping. So first we will check cancelled completed for both. Not this one. Yeah, if our while running is ongoing, then if it's false, then stop jumping. That's it. So here we have set our jumping code, and one thing we already forgotten, and that is our reset while code. So now here, as we forgot, so the first thing will be take this, then set movement mode to walking, then call the decrease spring arm length, then set every variable we are using to false. So this one will be false, this one will be false, then this one will be false, then this one will be false, then this one will be false. So just add every variable you have done here so far, so that we can keep things, and length z value. Okay, so we forgot one more thing, and that is get player controller, and then set ignore move input to false, because we set it to true. Now we need to set it to false, and enable while run. This one is the event we used for resetting, so that one will be enabled, and pretty much it, our code. Now let's test if our everything we did is working or not. Okay, So now to test it, we will be needed here. I guess, wait a minute. Okay, so now if we play, you will see that when we press the right mouse, it is showing our line trace. But again, if we go close here, we don't see anything, right? Nothing is working. But if we go here, you can see something happened, right? So if we do like this, and what happened? So there are a few bugs which we will fix. Okay, so it is not calculating properly. Now the first thing we need to fix is our here the wall offset. Let's try this 70, see if it works. Also, one more fix you need to do pretty quickly. Here in our spring arm code, I forgot the value was 0, but you need to set it to the default value, else once you are decreasing, your camera will act weirdly. So fix that. Now let's see if our thing works. Yeah, now it is working pretty good. And again, if I try, okay, line trace is hitting, but it is not doing anything. That's weird. Yeah, it is working. So let's see. I guess I found where we did the mistake. Actually, we are using here our right vector, rotation. I guess we should not do this. So let's see. Get actor right vector. If we replace these with these, what happens? Here we are using our right vector for both instead of our actor rotation, because I'm confused that maybe because of our actor rotation, when we are changing our button, because okay, this will work. This method should work once you are playing as 8 directional uh, blend space. But if you are playing as one directional, like we are playing orientational, so this method should not work. So let's see for this if our this method work. And I have used this some other places. Yeah, here also we will change. And did we use any other places? I don't, yeah, here also. So here will be get actor forward vector. So this one will go here. I guess that's it, or I don't see any other code here. Okay, now let's try if this method works. Yeah, now it is working. And now if I do, you can see, but it is actually hitting but not counting properly. So I guess we need to check where we are doing the mistake, because if we jump and our angle is fixed, then it should work. If it's not working, that means there's some problem. So we can see that, yeah, it will work, it should work every time we give. So why it is not working is a question. But anyway, right now you can see our character is not doing anything because we have stopped our movement, what to say, input. So our character is not actually, moving. It is just standing idle, means its velocity is 0. So now we will solve that problem. So the wall offset you can try based on your demands. So let's come here. You can see that here we have toggled input. So what we will do here is increase this part and bring this part here. Okay. So here we will try for play anim montage, and this one will be this. Now here we will play two anim montages, one and two. So for these will be needed some help of delay. So after that he will play this. So now for these, I have a question. Why my characters? Okay, I guess I forgot about this one. So let's see where are we are making mistake. Max height. Did we declare our max height? I guess yes, not. So it should be 30. And now for the animations, I am using actually Parker, but you can use any animation you want. So let's go UE5, wall run and horizontal. Here I have two kinds of animations. So for the animation, I guess we should make a function, not like this. So uh, play while run animation. Uh, okay, now not function, actually we need event, because function actually don't work with delay. So here we will make a custom event called check play while run animation. So you can see what I wrote. Now we will just paste this. Yeah, because in function you can actually declare the delay. So here for this entire part, sorry, let's bring this here a bit. Yeah, so now here we will call our play while run animation and connect this. So why I have created these, you will understand. So here we will take a branch and we will set this twice. So if our right while hit is true, then we will play this. If false, then we will play this. Okay. So based on that, what we will do is, first thing we need animations. So here from my thing I have, you can see these animations. So yeah. And on each animation, don't forget to enable root motion if you are using root motion animations. So this one now here from here I have started. It is almost point, let's say 65. So the delay will be 0.65 for the left one and right one, though we will check. So for this left one, we are using this left, so this value is perfect. After that, we will have this cycle animation. So this one. Now we will create all three as our create anim montage. So now we got them, and after we got them, we will select the start place here. Then after the timer, we will select the cycle, means the loopable place here. Now for the right part, again we will open this and check what is our timer. Yeah, I guess the same. So here again we will select these three, right click, create anim montage, and okay, save. Then we will select the start for these, and for these we will select the cycle. Okay, pretty good. Now let's see if our formula works. So okay, so why only this wall working, not other wall? I will show, don't worry. Okay, now we can see that it is not actually running in loop. Why it is not working? We need to check. Yeah, we can see that it is not working because the cycle animations should be in loop, not here, from here. The cycle one should be loop enabled where it is, yeah, loop. And we will do the same for this one. This one should also be looped so that it keep working instead of, let's try now. Still not working is weird. Okay, we will see this part and solve in the next episode. So till then, stay happy. And in the next episode, we will try to fix our bugs with the wall. And okay, before we leave the second episode, here is your, I mean, tips why only this wall works, not other walls. Because if we select any other wall, go to details panel, search for collision, you will see they are set to default. But in our code, what we have done is inside the line trace, if we go, you'll see we are doing object type. So this object need to be matched, else it won't work. So in this wall, if I select, you will see the collision I have set just did this custom. And after that, this one will be our wall run. That's it. So if you do this, your wall will now work and you can perform the moves here. So that's it for the second episode. Why these are bugs are happening, we will of course see and fix in the third episode. Till then, thank you. Keep coding. I will see you in the next episode. Assalamu alaikum. Allah Hafiz.